Hello everyone. So today we are going to do Leetcode daily challenge next permutation. So before doing this question, we should understand that what next permutation actually means. So as per the question, it is already mentioned that how the next permutation would be like. Like if we take example of this 1, 2, 3 only, then there are total 3 factorial permutations for this particular array. Okay, before understanding the question, let's get to the time constraint of this question. So we are given with such a lower constraint that the num start length could be 100 and nums of I it is again 100. That is, but nums of I value um, they are not required much to be considered as part of this question. But this nums dot length need to be considered that yeah, we would be having at least one number in our array, or we could be having at most 100 numbers in our array. So this is what is being required here. So as per the constraints, we could also use recursion here, and it could even go to a time complexity of 2 raised to power n. But the thing here is 2 raised to power n might not be, might be, but it can go up to exponential. That's the factor. Cost is 100 only. But here the thing is that this particular question can be done on the basis of a mathematical stuff which was being given by one of the Indian mathematicians, and we could read that on Wikipedia also. And we simply need to convert that mathematical concept into the basically that mathematical algorithm into the coding part. So that is the thing we would be doing today also in this particular question. So now, first thing which is required is to understand this question, that what exactly next permutation is. So when we would be given with this 1, 2, 3, then what could be its next permutation? It is already in ascending order. So for finding out the next permutation, we could simply fix this one and then simply swap these two. And after swapping that, we will be getting 132 as our next permutation. But this thing won't work every time. So for finding out the next permutation, we have a particular algorithm, which is something I can consider that. So here also in this question, the thing which I was telling that 1, 2, 3, and swapping that, fixing that. But here if we simply fix this 2 and swap this, then again it won't work even, right? So that's the reason. And while the next permutation of array 3 to 1 is 1, 2, 3, this is because all are in descending order, so we won't be able to make another possible combination. So what we are doing here is simply sorting it in lexicographical order, because 3 to 1 does not have a lexicographical larger rearrangement. So for this next permutation, we simply want to have a next lexicographical larger rearrangement, and that's the need of the question. So, and next thing is the replacement must be in place and use only constant extra memory. That is, we simply can't use any other data structure to be used into this. So that's why here comes the part for all mathematical things to be done here. Because if we would be using any other data structure, then it doesn't simply as per the question. So that's the thing. So here 1, 2, 3, and then it becomes 1, 3, 2. And then 3 to 1, the next would be 1, 2, 3 only. 1, 1, 5. How we could make the next larger one is by simply having this 5. This is largest. If we go from backward direction, back to front, then 5 is the one which is larger than 1. And then after swapping, we simply get this. And one more thing is there, because we want the next larger one, right? So the thing is, after getting this particular number, which is the one after means when we go from back side, is when we go from back side towards the front. So we are simply doing this, right? Swapping both of them. When we find a number which is basically smaller than the present number, right? So we simply swap them. But the thing is, then again there would be the thing that for all the numbers which are here, we are required to simply reverse them. Why we would be reversing them is so that uh, basically we would be taking them all in ascending order. That's the thing we would be doing here. So that this particular new number, which is formed, is the one with just the next permutation, basically the next largest permutation which is being permitted, not the one which is the largest of all. So that's the reason we would be required to reverse here. So this is how I gave you the brief idea that what is required to be done in that particular algorithm. Somehow you would have got the idea, but now let's make it more clearer. So here's the thing, how I can explain you about the same. So now, if we take example of this particular thing, that 1, 2, 3, then how many permutation we could have? We could have 3 sectoid permutations, right? So how we could get towards this next permutation? This is what I've explained here. So when it is 1, 2, 3, all are in ascending order, right? So for getting the next larger permutation, what we would be doing is, we'll simply check, means from backward to forward direction, we'll check that which is the one which we encounter just a smaller number from the present number. That is 3, which would be a present number. And then we check anyone which is smaller than 3. Yeah, it is 2, right? So we'll simply swap them. And after swapping them, we simply need to reverse whatever is there. So once 3, 2 came out to be there, so we need to swap simply after 3. Means this particular 3 means at 0, 1, first position is there, and then we are simply required to reverse after this first position, that is this particular. And when we do so, because it is just a single position, then reversing a single position with single position is simply the position itself, right? So that's the reason it begins 1, 3, 2, and our next permutation is 1, 2, 2. Now we are repeating again that 2 is there, 3 is there, right? Then if we go from back to front, then here we can see just 2 is there and 3 is there, right? So 3 is greater than 2, we can't take this. Then 1 is smaller than 2. This is the required number. So that's why what we would be doing is, we will simply swap both of them. And now, as we have swapped from this 0th index, right? So leaving the 0th index, and after that it was 2, 3, 1, right? So we would be simply required to reverse this 3, 1 into 1, 3. So this is what we would be doing here. And then comes the part finding out. Now its next permutation is this one. Now we again repeat that process again. So it is simply 3 is there, and when we go towards the forward direction, the 1 is there, which is basically smaller than 3. That's why we swap both of them, and then we reverse but here it is single number, so it will remain as it is, and thus now it becomes 2, 3, 1. Then after 1, we go towards the front direction, right? Then we get this 3, which is greater, and then we check 2. We find out that this is the pair, which is something like 2 is smaller than 3, right? So in this case, we swap both of them and then reverse from this particular process. That is, we would be getting this 3, 2, 1, right? And then we would be reversing it, so it becomes 3, 1, 2. And this is our next permutation for 2, 3, 1. Then comes the part of finding out the next permutation for 3, 1, 2. When we find out the next permutation for this 3, 1, 2, then first 2 is there, then smaller than 2 is 1, right? So here we are required to swap 1 and 2, so we swap them, but then we need to reverse also. So while reversing, we find then again it is just one element only, so the answer remains as it is, and then we find out that this is our next permutation. So basically we have covered all these 6 permutations here. So yeah, 3 to 1. After that there won't be any new permutation. Basically it will again loop out to 1 to 3 only. Means after 3 to 1 it will be again 1 to 3, and then again whole cycle would go on. So why I have given or explained this example is just to make you understand that how we are required to find out the next permutation. So basically, while finding out the just next permutation, we are required to have specific things in mind, that how we would be proceeding with that particular algorithm, in this sense, that how our next permutation would be like. So from these examples, what I observed was that if a given number is in descending order, means this particular thing. Descending order from the front direction only, not from the back direction, I'm saying. From front direction only means normal descending order. Then we are required to reverse it, and its next permutation will be in ascending order number. That is this 1 to 3. Means this 3 to 1 would be simply having its next permutation as this 1 to 3. Because what we are required to find is just the next lexicographical order in descending order. Basically, we are simply required to find out the next we can say here it is lexicographical small ascending order only, but the thing of which is required in this question is that we are required to find out the next larger number, just larger number from the one which is presently we are having. So that's the thing is here. Now the next thing is, this is also one of the observation also, and even the algorithm part also, that what we are required to do in this particular question. The thing is, the step 1, which is we are required to move from the back, the way I was showing here, and then find the first pair, because we were only required to find out the pair, because here the thing was that 1 and 3 was not there, but 2 and 3 was there, right? So this is that first pair which is in descending order towards the front. Basically, all of them which we are finding out is that descending order towards the front. And in other words, we are required to find out the first pair which is in ascending order, means normal ascending order when we go from front to back direction. But as we were traversing from backward direction, so for simplifying it, I just chose this wording that the first pair which is in descending order towards the front. After we would be having a scale towards the front, so that's why. So for example, here we can simply observe that this 4 is there, then 5 is there, then 6 is there. All of them are in ascending order if we go from back to front, right? But the 6 and 3, this is the first pair we can find out which is in descending order, right? And in this 6 and 3 also, we are required to capture that particular number which is the smaller one. So we will simply store this 3 with us. Okay, it's complete. These are simply required to this 3 with us. And then step 2 would be, let's move from back again. So we are again moving from back and we have stored this 3 with us, right? Now find the first number which is just greater than previous selected number. That is this 3. We are required to find out the first number which is just greater than this particular number 3. And okay, we simply find, if we take this example only, then we find out that number at the first moment only, that is 4. But there could be a case that we are not able to find out the first number as it is, like here. So for just explaining some with more examples, I've simply chosen this example that yeah, number is 3 only, right? But it might be a case that now 1 is smaller, right? But 5 is greater, and even 5 is not also a number which is just after 3, right? Because just after 3 is 4. So that's why I've taken this example that this is the one which could also be a case, and in this particular case, we are required to swap both of them. So this is the thing which we are required to do, and after swapping them, we are required to do one more step, that is the step 3. But in the step 2 only, there could be two cases. Either we would be able to find those two numbers, or there could be this case also, where the things are that we are moving from back to front and we are not able to find out any pair as it is. And then again, we are trying to find out this, and then again, the thing is like that. So in that direction, these two cases arise. And then after this, we will swap both of the found numbers, means for this case 1. And then in step 4, we are required to reverse from that point where the first found number was. That is this 3. This 3 where it was found will mean this 3 and this 3. From there to end, we are required to reverse all the numbers. That is the thing which we would be doing. Basically from this particular index, that's what I required to say. Because when we will swap, this 3 would go towards this 4, right? So it will be something different. But the thing is, we are required to reverse from this particular index in just after from this index. And in this reversing case, this also covers the observation 1, because when we are not able to find out any such index, then it will reverse from this only, right? So in that case, this case is also considered. It will reverse this one also. So after this explanation, let me walk you through the code. So for that coding part, okay. So here the code. This code is somehow similar to that Leetcode solution only, which is being in the official solution. But I've tried to explain with some comments and even examples so that it becomes much easy. So what we are doing is that we are first taking the last second number, means the index for the last second number, and here we are doing first thing is we are running the loop until we reach a pair where first number is smaller than the second number. That is this particular, that we are going from back towards front and we found this pair 3 and 6, right? So here 3 is that number. So this ith index would be stored for this, that is 0 1. First index would be stored here. Now we got that ith element which is smaller than the I plus 1 element, right? So we would be having this I with us, right? And we are having this check because there could be a possibility that I became negative while doing this, and this case will follow in that particular case when it is in all descending order, means that 3 to 1 case. So that's why we are required to have this check. And then we will be again traversing from back towards the front. This is for the case that we want to find out that number with whom we are required to swap. So running this loop until we reach a pair where last finded number is smaller than now finded number, right? So here the thing is that this 3 was the number and now we are required to find that particular number, so we found that as the 4, right? So here they would be having this index and now we are required to swap it. So now we swap them and now a new would be something like this, that is this one. 4 and 3 are being swapped, right? And after that, we are simply required to reverse. So this is what we are doing. This was the index where 3 was earlier, right? So after that, everything has been swapped. So this is how we are required to code this particular question. And even rather than using the inbuilt reverse and swap function of C++, as it was also made a new function, so I've also so means these reverse and swapping functions are there, which we are where just by using two pointers we have swapped and reversed. So this was all. And the most important part, the time complexity. So the time complexity for this solution is this reversing part. It also takes the time complexity as order of n, and then this swapping part, this particular also takes the time complexity of order of n, right? And this particular whole thing which we are doing means before this swapping and reverse means at the worst case it could also go till time complexity of order of n, right? Because there could be a case when we are not able to find out that particular number, right? So yeah, in all these cases, and even all these are not nested ones, right? So they would be simply added up with the time complexities only, and in that scenario, the time complexity is simply order of 3 into n, right? Which is simply equals to n, means order of n only, and the space complexity as per the requirement of the question. We are not using any extra space also, so it's constant only and it's order of one space. So this was all about this question, and this was the question which was asked from me in my first interview round of Amazon, and at that time I was not able to come up with such type of solution. Basically, was able to give the partial solution, but not the whole solution. So yeah, this was all. And if you have any comments or any doubts or any other solution of your choice, you could simply comment down. So this was all from my side. So thank you.